So what I have here is a simple implementation of the array mapper, and I wanted to expand on a bit on this module that I'm working on. So I wanted to add reduce here. I know it's a silly example, but it's kind of a fun thing to build. Reduce is obviously already implemented in the JavaScript standard library, but it's a fun exercise to build your own reduce. So I have a test file for map here. So let's copy it and name it reduce.test.js instead. Open it on the side here. And we could actually delete all of this and just name it reduce. Make sure we import reduce instead. So for our first test case, what is reduce actually doing? Well, reduce is a way of combining or joining, or I wouldn't say joining, but combining elements into some end result. It's a bit generic the way I describe it there, but that's because reduce is very versatile and quite powerful, honestly. So let's look at a simple example here. Let's say we want to, it should summarize a list of numbers. So for this use case of reduce, I'm going to have the input array be 1, 2, 3, 4, 5, and we get the output from our reduce. And the way reduce works here is that it takes a function as the first argument, and it takes an initial value as the second argument. We expect the output to be, we want the output of, so the sum of these numbers would be 1 plus 2 plus 3, 4, 5. Could actually put it like this. Like that. Let's see what happens if we run this. And I only want to run it on reduce actually. So fn is not defined, right? Let's create fn here. So this will take the callback function that you pass to reduce receives 2 arguments. So the first argument is the accumulator, or the current version of the object that will in the end be the sum. So for this scenario we could actually call it sum, and the second argument will be the next element, so in this case a number, and it should return sum plus equals number. So this will just take each number and add it to the existing sum. So while stepping through this, you could think about it as grabbing the 2 here and adding it onto the 1, so we have 3 in total. Grabbing the 3 and adding it to the previous sum, which is 3, etc. The initial value here should obviously be 0. So if you run that instead, reduce is not a function. Alright, cool, because we don't have reduce in our actual model here. So reduce, the way I explained it, takes a function and an initial value. So what if we just return initial here just to get started? Let's see where it gets us. So we expected 15, but we actually received 0 because we didn't really execute the callback function that we passed in. But the thing is that I actually forgot something here. We need to pass the whole initial array as well. So let's do that too. So when the way you should think about reduce is that it will execute for each of the elements in the array, and it will return the end accumulated object, starting from the initial and moving through each element of the array, executing the callback function that you pass it. So the way you could think about this is let's create an output object here. Or let's actually name it accumulator. And we'll let this be initial from the beginning. Return the accumulator. So for each element here in the input, what are we trying to do? Well, we need to recalculate accumulator by calling to the callback function over and over. So we need to actually assign accumulator the return value while passing accumulator and element here. So what this does is it gives the callback function a way of acting on each element and combining it with the previous accumulated object here. If I do this, it says that input is not iterable. Okay. So why is that? What is input here? Let's see. So input is actually the function. Okay, I forgot to save the test file. So with this in mind, we have accumulator is not defined here, and it's actually a typo by me. Let's call it ACK to get rid of the typing problems. What now? Assignment to constant variable, right? Because on line 16 here, we're constantly reassigning the variable ACK that we create on line 13. But the way when we create it as const, we're not allowed to change the actual reference of the object. So we need to make this a let. And now it says accumulator is not defined, right? Because we forgot that we renamed the variable. And now it passes. That's kind of cool, actually. So we can actually summarize a list of numbers now using our reduce function. So we could look at something a bit more complex. It should be able to index an object. This is a somewhat normal use case for working with objects in, let's say, a web app. We want to have a list of objects, and we want to create an index object out of this list of objects. So what's an index object? In this case, that would be, instead of this array with each object having its own ID and name, we'd create an object that looks something like index object that would have the keys be the actual IDs and then the object. And this makes it way easier for lookups, a bit faster, and can make the code a bit nicer in some cases in React and stuff. So this is what I'm going to create using the reduce. So for the input, we have two objects and we know what we want to return. We don't know what the function should just actually be, instead of a sum here, we're receiving an index object, and instead of a number, we're receiving an object. And the way we want to do it here is we want to assign index, and the key should be, object here. Oops. Object.id should be the key, and that should be assigned object. And then we just return the object here. Okay, that's cool. So we know what the output should be. We want this to be 1, should be ID1, name Anton. ID2 should still have the ID in there, and the name should be Matteus. Let's end the index object as well. Did I miss something? I don't think I did. Oh, maybe there's a bracket too much. So it tells me now that we expected object.isEquality. Okay. What about to equal? Never really learned these comparators that you get in Jest. I think there's also one that's called to strict equal. Okay. Let's look it up. Just compare to best way to compare to complex objects using matchers. Common matchers to equal data to equal. So what's the problem here? To equal, and we received 0. That's weird. Okay. The initial is 0. We assign 0 to ACK, and then we always pass in 0 here. So that would make our... Okay, yeah, I get it now. Because we're always passing 0 as the object here. We need to make sure that the initial is something a bit more fitting to the domain or to the solution that we have right now. So we're working with objects, so we want the initial object. You can think about it like this. Basically, we want the default value to be an empty object. And this works. That's cool.